Well, the main reason why people would do that has to do with how statisticians perceive interaction. Interaction for a statistician is bad news. Because when there is no interaction, we can talk about the two inputs separately. So, you see, in the black box, there are a number of inputs, and the natural question is, how does this input influence the output? How does that input influence the output? That is the primary thing that a statistician is trying to find out. Interaction spoils the entire fun by saying, you really cannot talk about how the input is connected to the output. They are inextricably twisted inside, and it is the combined effect which is actually influencing the output. So all that you can say that things are twisted, and I cannot say anything more. So interaction is not a good news for a statistician. So it is something like this, that suppose we work with some mixture like this. So the mixture that we are using is like glucose water. Now in glucose water, it is water plus glucose. So you can understand what is the property of glucose. In the glucose water, you add more glucose, it becomes sweeter. You add less glucose, it is less sweet. And water, you can see, that's why it is liquid. But when you have water that is made up of hydrogen and oxygen, by studying properties of hydrogen and properties of oxygen, it is almost impossible to make any sense out of property of water. So water is just a new thing. And that is what is bad news for a statistician, because we cannot say that since we have studied hydrogen and we have studied oxygen, we understand water. It's just a new thing, you have to study it on its own. But if it is like glucose water, then both the things retain their properties, they are just put together, added up. So that is like the no interaction case, the additive model, and this is like the interaction case, non-additive model. Well, it is a pretty similar situation in case of this interaction versus non-interaction. So when we have these two models, or these two formulations of the same model, then the reason we prefer this over that, because this one is something like saying the two things are inextricably mixed up. So mu ij, you study each of the ij's pairs separately, estimate their mean, and be done with it. On the other hand, this model says that this is the good part, the additive part. So had this been the only thing, we would be very happy. So that's the fun part. Mu plus alpha I plus beta j. If we just stop here, then we can associate interpretability. We can interpret the effect of variety 1, interpret the effect of tilt slope and things like that. But this is the spoil sport. If there is this gamma ij, then everything is ruined. So here I am expressing it as two parts, the fun part and the spoil sport part. And the reason is not that we are trying to estimate this gamma ij's at all. The main reason why we put it is to test whether these things are present or not. So this is the main thing and this is the bad. So this is the good thing and the bad thing. So by separating the good and the bad in the same model, this allows us to test statistically that the gamma ij's are all equal to 0, in which case we can say that we are in the no interaction case, in the additive case. And thus what we are achieving here visually, we can do it using some statistical method by testing for gamma ij's. However, if we use this model, then we cannot do any simple test on the mu ij's which will capture this idea that the lines are parallel. Of course, we can do something complicated like mu 1 2 minus mu 1 1 equals mu 2 1 minus mu 1 2 1, or some such thing, some complicated stuff. But here that test becomes very easy. All the gamma ij's are equal to 0 or not. If at least one gamma ij turns out to be non-zero, in that case we merely report that. So we never try to really estimate gamma ij hat. So we do not care about the interpretability of the gamma ij's. We merely report that life is difficult here. They are not all 0. So they are not parallel. I cannot really talk about the effect of variety or effect of tilt separately. You have to always work with a pair. That means you actually have to fit this mu ij things. Work with the FD combination separately. That's it. Now, whether we should really do that, that will be dictated by whether the gamma i's are 0 or not. That is why people, when they first have some linear model problem with two factors, they will try to fit this model and then will test whether this is 0 or non-zero. If 0, they are happy, they will go back to the additive model and give various interpretation, estimate alpha and estimate beta. If these are non-zero, then immediately they will merely say that we have interaction and stop at that. If we want to proceed further, you work with the Selmin's model, which effectively means you work with each possible combination separately. So we work with only, say, variety 1, and for variety 1 you figure out how the tilt influences it. Then separately work with variety 2 and again figure out how tilt influences that particular subpopulation of the problem. Again work with variety 3 separately and test for the difference between the tilt slope and tilt like that. So that is why this particular model is more popular. You always start with this. And when we looked at this interaction plot, we basically did a visual test of whether gamma ij's are 0 or non-zero.